Hello. Some of you may have watched along with the in class while we did the fraction guided practice, fraction arithmetic guided practice. We're going to go through it again for a video for those of you who missed it, and you can fill in if you did not hand in the guided practice. So you can follow along with this and fill out the form. Okay? So let's look at the first example. The first example, it asks a question that you may remember from the Math as a Language video that we saw in the first week. This guy says he can get a 5-year-old to do basic arithmetic if we do, we can get a 5-year-old to add fractions if we simply write it like this. 1/3 plus 1/3 is 2/3. You don't have to know what a third is. For all you know, it's a word from a Dr. Seuss book. You don't have to know what a third is to know that that's 2/3. It's basic logic. But we know that a third is a fraction. So if this is true, then we know that this must also be true. 1/3 plus 1/3 is 2/3. As confirmed here, we also know it's true here. All right? So, the convenient thing here is that my labels match. But our labels may not always match. We have to fix that. For example, if I wrote one pair of apples plus 1 dozen apples, I cannot say this equals 2 anything, right? Because I might as well be adding apples and oranges. 1 pair of apples and 1 dozen apples don't really add, right? In order to add them, I must convert my pair of apples to what they really are, which is 2 apples. And my dozen can be referred to as 12 apples because a pair is 2 and a dozen is 12. So now that my labels match, just like with the thirds, I can now add this. And I get 14 apples. Okay? And that is the answer to the third question. All right. Now, in the same way that 12 apples is a dozen, 12 dozen, that's 12 groups of 12, equals 144. 12 dozen, which equals 144, is also what we call 1 gross. That's the actual word for it. A gross is 144. And I tell you this so we can ask this next question. What is 1 gross of apples plus 2 dozen apples? Now, just like with our pair and dozen question, I can't add these as they are, but I can substitute. I know that 1 gross is 144, and 2 dozen, well, that's 2 sets of 12, that's 24. So we have 24 apples. And altogether, we have 168 apples, which is the answer to the next question. Again, it's just all about converting my labels. Now, occasionally, you may see a problem which asks this. How many dozens of apples? We saw 2 dozen apples here, right? But my 1 gross, I can't add a gross and a dozen, but we want to know a dozen. So if I turn it into just apples, right? If I get 168, I can't write 168 dozen. That's an even bigger number that would give you way too much. No, my answer has to be so many dozen. So because the question asks for dozens, the numbers that I'm adding must also be in terms of dozens. So my 1 gross, instead of writing as 144, I'm going to write it as 12 dozen. 12 dozen apples. So now I can add 12 dozen apples plus 2 dozen apples is 14 dozen apples. Okay? This next question that asks about how many gross is that? Well, if 12 dozen equals 1 gross, then something to know, 1 dozen isn't a whole gross. 1 dozen is just a part of a gross. It's one little part of it. 1 part out of 12, because we need 12 of these dozens to make a gross. So this equals my 1 part out of 12 gross. And so 2 dozen can be said to be 2 parts out of 12 gross. Which would mean that 1 gross plus 2 dozen, which instead we can say is 2/12 gross, equals 1 and 2/12 gross apples. A gross of apples? It's not this many gross apples. It's not like they're rotten or anything. But that's that idea. We can convert my labels in order to more easily add, or really to be able to add at all. You can't add until your labels match. And sometimes that involves converting like this. Converting is when we change our number to give us a certain label, or in this case, like a unit, or a term like dozen or pair or gross. Okay. Next, when you go to the next page of questions, we're going to see this. You are having some friends over, and you have to buy enough cookies to be fairly shared with everyone there. But one of your friends might not show up. You aren't sure if there will be 3 people or 4 people. So we might have 3 people, right? Let me try and draw people really fast. You might have 3 people to share, right? Or there might be a 4th person. Right. So we might have 3 people or we might have 4 people. Now, we want some number of cookies where they can all be fed in each case. Now, we think of a number that can do that. A number that can be broken into groups of 3 or into groups of 4. Well, if these people this. So this way, each of these people will get 3 cookies, right? Or this way, each of these people will get 4 cookies. So, if we get 12 cookies in all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then we will have enough that can be shared fairly, either 3 for each or 4 for each, whether this 4th guy shows up or not. Now, I kind of showed here that all we have to do is multiply and we'll get an easy answer. Even if, say, in the next question, more people show up and we have either 5 or 6 people, and that extra person is still a maybe. Still, we don't know if they're going to show up. We can apply the same reasoning. Okay? We might have six people here, or we might have 5 people here. But in any event, right? 30 people, or 30 cookies. 30 cookies will feed either 6 people or 5 people. But the same logic that we solved this problem. With the 3 and the 4, the same reasoning that gave us 12 can also give us 30 to feed either 5 or 6 people. So 30 is a number that can be divided by either 5 or 6. In the same way that 12 can be divided by either 3 or 4. Okay. So that all being said, our parties are getting very popular. You're known as a really good planner who seems to always have enough to go around regardless of what curveballs are thrown. You are such a good planner that not only are more people showing up, but more people are giving you the maybe treatment. Now you might either have 9 or 12 people at the party. So we'll either be feeding 9 or 12. But if we use the trick we did earlier, we multiplied them, got 108, that is way too many cookies. And we are going to run ourselves broke buying that many cookies. So we want to know if there's maybe a smaller number we can divide cleanly by either 9 or 12. And we can go about it. We can see. Let's say maybe we have 12, 9, 24, no, 18, 36, 27, 48, 36. Uh-oh, look. So these numbers can feed groups of 9, and these numbers can feed groups of 12. And we find here that 36 is able to feed either groups of 9 or groups of 12. Fun fact. You don't need to do this, but this is just a fast way to do it. If you can identify a number that goes into both 9 and 12, in this case 3 times 3 or 3 times 4, you can use the multiplication trick, and whatever number goes into both 9 and 12, you can just divide by that number. 1 and 8 divided by 3 will give you the correct answer. If you pick the biggest possible number that can go into one of these two, if you pick that number and divide your product, 108, by that number, 36, to get 36, that will always work for you. There are other examples I could show. let's say if there were, actually the last one was 36, but I wanted to show a few other examples. We did 8 or 12. Those both divide by 4. That's the biggest number that goes into both of them. If you multiplied and got a large number of cookies, 96, you can divide by that 4. If you worked it out, you'd get 24. And 24 can share with 8, and 24 can also share with 12. And that is the lowest number with which that works. And yeah, that works really well. The reason why we didn't use that with 3 and 4 is that the lowest number that divides them both is 1, right? 2 doesn't divide by 3 and 3 doesn't divide 4. So 1 is the lowest number that divides both of them. So you can do that, but you should be doing 12 divided by 1, which is still 12. And same thing for 5 and 6. This marker's dying on me. The lowest number that divides both of them is 1. And so 30 over 1 is still 30. So that trick always works, it's just it's not always useful. But if you can find a number like in the case of 9 and 12 or 8 and 12, where it divides both of them, then that will be helpful.